I'm going to sneak this in. It's one more, I guess, kind of flip lecture. Just moments ago, it was pouring rain so hard. This is Monday, I guess your day right after spring break. It was raining so hard, and you can just imagine what these storm drains are like all around our neighborhoods with water gushing down them. And I imagine a lot of you have gotten stormwater samples at this point, and I'm afraid we're not going to be able to follow up on that. And so I wanted to just, I guess, do a little video plug on what we were going to do. No need to take notes, just kind of hang out. And so just remember, water is a polar molecule. It means the hydrogen and oxygens aren't sharing the electrons equally. And so it makes it so it's a charged molecule. You got a positive side and a negative side. And so that water molecule starts to behave like a magnet. And as it goes through the watershed, anything else that's a magnet can be attracted to it. So what we were going to do is test for these things in the lab. Nitrates, ammonia, copper. Notice that they are ionic compounds and ions with charges here. Oops, that's supposed to say Cu2+, but that's what it is. And so they get attracted to the water molecules. Copper comes off our brake pads, by the way. Every time you hit the brakes in a car, a little copper comes out. pH, also an ionic thing with hydrogen ions. Total suspended solids. Phenols is a type of detergent from soaps and things like that. And then we're going to look for petroleum and oil products too. And so I was going to have you make a hypothesis about which community you think would have the most pollution in it out of our, the communities feeding into MA. First, a recap of a watershed. And so if you remember, the last thing we did together was we did that groundwater simulation thing where, again, you can see water taking other polar or charged things, in that case dyes, and moving it through the ground. And so when we think of watersheds, we want to be thinking about a couple things. One, letting the water recharge into the ground. And so if it just hits pavement and it takes off down the pavement, that leads to groundwater issues. And two, how do we use the water and distribute the water? And if you remember State of Thirst, that film you saw the other week, it was really getting into, like, there's some competing needs of water. And then to me, it's amazing how water just zigzags all around California, and pipelines going hundreds of miles. It's really incredible and complex. But now it's like, so how do we keep that water clean and not polluted? And so there's two things I want to, I guess, just review with you guys. I guess there's two approaches. One is pollution prevention. We can, of course, just stop polluting. We're going to stop putting down the fertilizer. We're going to stop having oil leak all over the place. And so that's pretty straightforward. But really, we've got pollution out there, and we're going to continue to pollute. And so we need to figure out a way to control the pollution. What mechanisms can we use to make it so the pollution is contained? And so there's two types of pollution that we want to be thinking about. We've got point source pollution, and that's where you can just point at it. The source of pollution is easily identified, like these pipes coming out here. Also, like here's a chimney, I can point at the smoke. There's a huge source of pollution right there. Maybe it's a power plant, or here's a sewage plant that's discharging, things like that. Or if there's just one CAFO in a region, we know CAFOs have big runoff issues. Okay, all that runoff came from that CAFO. And so if it's point source, we know where it's coming from. It's easier to address, easier than non-point source. And so what this is where you've got lots of diffuse sources, and there's several, and sometimes they're even moving. Example, a car leaking oil. We've all seen it in parking lots, where you see that oil shine. Which car did it? We don't know. It's non-point source pollution. Residential area like lawns and gardens all around our neighborhoods, they've got things running off. Where did it come from? We don't know. Or in the Central Valley with bigger farms, but there's so many of them. Of course, there's some pesticides that are running off their farms, and we can find them in the Delta water system. What farm did they come from? We don't know. And so it makes it a lot more challenging to manage. And so we want to figure out how to control that pollution. What can we do to make it so so that the impacts aren't as severe. And so I was going to have you make a hypothesis, and we're not going to unfortunately be able to do that. But what I will leave you with is what we were going to actually do. We test the water, and then here's a list of some of the Environmental Protection Agency benchmarks. And if you can look carefully here, you'll see, like, for example, nitrate. It says 0.68 milligrams per liter, or parts per million. What that means is the limit, according to the EPA, is 0.68 ppm. Anything above that is in violation, and it is illegal for stormwater runoff. And that goes back to the Clean Water Act. And so what we found is, out of all those things we've tested, and of course this depends on what we're actually testing. A lot of people think Redwood City is going to be the most polluted because we've got more traffic in industry here, or maybe it's East Palo Alto, or there's different ways to look at it. What we found for the things that we've tested is nitrates is the big, the one that has the most violations, and sometimes it's like 10 times over the legal limit. And we should know that it's the biggest water pollutant in the entire country. It's not just the peninsula. Where is most of the violations coming from? Atherton and Portola Valley are typically the ones with the biggest, I guess, infractions. And if you just think of like big green lawns and gardens and lots of fertilizer, and that's where your nitrate's coming from. And so, interesting. In real science, and I'm sorry we're not going to actually be able to pull that off because it's relevant. It's from our neighborhoods. Last thing, and so if you look around town, you're going to start seeing this kind of stuff more. This is by where I live in Redwood City. Here's DeLucchi's. Here's Marsh Road right there, and there's a Starbucks there, and 101's over here. But if you know this area, DeLucchi's just totally remodeled a couple years ago, and they've got this new parking lot. And you can see there's two spillways here for the runoff from the parking lot to come over here and soak into the ground to recharge. And when it does that, it gives these plants an opportunity to suck up that whatever pollution is in that water coming off the parking lot. It's pretty cool. So we want to contain that pollution and control it. And sometimes the plants even dismantle it. They like kind of digest it. If the water gets too much, it goes down this drain. And so I've seen this stuff happening all over my neighborhood. In fact, I was just taking some pictures the other day when I was walking around the block. Keep your eyes peeled. And the MA parking lots got some of this. Portland, Oregon's developed a lot of like little rain spillways too in their community. And so the point is, we're getting smarter about how to develop our watersheds in a more environmentally friendly way. Thanks for listening in. Hope that was interesting, and I'm sorry we're not going to be able to do it in class. But keep thinking watersheds.